So let's then go to the paper by Farrell and Shapiro, which is actually about the Cournot market, merger in the Cournot market with asymmetric firms and where there's cost efficiencies involved. So typically, Cournot competition with asymmetric costs, that was a typical situation. So firms will typically have varying cost levels in a particular market. What's also typical, of course, is that even before this merger is going to take place, there will be some market power. So it's already Cournot market, of course, before the merger, and we might be worried. Of course, we want to investigate. Well, what's the total effect of having a merger in such a market? So obviously, there's going to be market power and price effects that might be detrimental, or will typically be detrimental. Will often be detrimental to consumers, but of course we have the cost efficiency that might offset this price effects. But there's an additional welfare benefit here, and that is that mergers, since these firms are not symmetric, they will reshuffle production. So the non-merging firms will tend to produce more after the merger than they did before. They will take up some of the reduction in quantity that the merging entity is achieving. And actually that reshuffling of production might be beneficial, in particular if those firms that are not involved in the merger are actually the more efficient firms. So the insiders will obviously re-optimize their production. And typically, if there's only small cost efficiencies involved, they will reduce their output. But indeed, these outsiders, these rival firms, in response to that reduction in production by the insiders, will actually expand their output, and that creates some efficiency effects if those are more efficient. So what Farrell and Shapiro analyzes, well, first of all, if there's cost savings from this merging firms, well, that might actually lead to lower price, right? In spite of this market power effect, and the cost efficiency effect might actually dominate, and then consumers are actually better off, and that would be a very nice outcome. So they ask the natural question: so how big should these cost savings be to lead to lower prices in the general Cournot model? And secondly, even if consumer welfare might go down because prices go up and total quantity gets reduced, still we might have this, a gain in total welfare as a result of the change in cost, but also as a change as a result of this reshuffling of production of the different firms, hopefully to lower cost firms. So that's basically the aim of their analysis. So what's the model? So we look at a Cournot model with n firms, but now an asymmetric one. So a typical firm I in this out of these n firms has some cost function, which is C sub I, which depends on its quantity produced Qi. And we look at a homogeneous good market with some demand function P of Q. So obviously homogeneous good, so we're interested in the total quantities here. And total quantity, of course, is the sum of all the individual quantities produced by these individual firms. So that means that the total profits of such a firm will just be the total price, which is the same for all these firms, which depends only on the total quantity produced, times the quantity this particular firm produces, that is the revenues, minus the particular costs that this particular firm incurs as a result of producing its share Qi, or its quantity Qi. So what we're going to look at is a merger between two of these firms. So let's just name those firms 1 and 2, so the rest 3 up till n will be the outsider firms. But firms 1 and 2 are the merging ones. They will fuse together into one firm, and that merged firm is going to be referred to as firm capital M for merger. And let's assume there's going to be some cost efficiency. So this merged entity will have some costs Cm of its total aggregate output Qm after the merger. And we are interested, of course, first of all, in saying something about the equilibrium price as a result of this merger. So the first question is, when will price go down? So when will consumers indeed be better off as a result of this merger? Well, when does that happen? Well, a decrease in price means, of course, an increase in the aggregate Q, the aggregate quantity that's going to be produced in this market. Now, what is necessary for this is that the merged entities, so these firms 1 and 2 together, they must actually increase production for this to happen. So if total quantity goes up as a result of this merger, so price goes down as a result of this merger, that will only happen if at least the merging firms are going to produce more because their costs are going down. If merging companies are going to produce more, then obviously the rival firms are going to produce less because, as you know, in Cournot markets, best responses are downward sloping. So more output from firm 1 and 2 jointly is going to reduce output from firms 3 up till n. But in the end, they will not offset the complete change in Q by these insiders, but they will actually offset it partly. So there will be a smaller but still positive increase in Q as a result of the merger. So the question might be, or the question will be here is, that will be interesting here is how much do these outsiders actually offset or contribute the change in the total Q? So if indeed total Q expands, by how much will the outsider firms, the I equals 3 up to n, by how much will they indeed contract their own production Qi? So we can get a feeling of that, or a measurement of that, basically by looking at their first order conditions. So the first order condition I wrote here, so let me also write that actually on paper, and then let's see what we can deduce from that first order condition in terms of the responses, best response essentially, if you wish, that that outsiders will have to a reduction in total quantity. So here on paper, let me look at the total profits. So I have total profits for each individual firm I, particularly also firm 3 up to n, is going to be P, which is a function of total quantity Q, because this is a homogeneous good market, times Qi minus the cost that this firm I is incurring by producing its Qi, and of course this total Q is, as I mentioned, the sum over all I's over all firms of, sorry, it's no point here, Qi, so the sum just of all quantities. So what are the profit optimization conditions or first order conditions for firm I? Well, that's of course just going to be, they're going to make sure that their partial derivative with respect to Qi is going to be 0. That's going to be the first order condition if these firms are actively participating in this market. So what does that look like? Well, since Q actually also depends on this little q, we'll have two contributions here. So there's one contribution where we measure indeed the extent to which little q is actually part of the big Q, so the individual quantity is part of the total aggregate quantity, so P prime times Q, so it's just a 1 basically coming from this derivative, times Qi. Then we have a second contribution, second part here from taking the derivative of this Qi, little Qi here, so that is just PQ, so that's from the product rule if you wish, minus the derivative of cost, so the marginal cost if you wish, and that should be equal to 0, right? So this is the first order condition. Now this condition relates, if you look at this as a function of big Q and little q, it relates big Q to little q. So this is going to hold always for these outsider firms in the equilibrium. So this condition will be valid in equilibrium. So we may ask, well, if in the equilibrium total quantity is going up, what will necessarily hold for the individual quantity Qi produced for firm I? Or we can look at this as an equation which relates big Q to little q. And you can actually figure out what's the derivative of the little q with respect to the big Q. So if total quantity capital Q goes up, or what must happen to individual quantity little q, or in other words, what is dQi dQ? That's what we want to know. we can work that out by actually taking the derivative, the total derivative of this condition, which basically is the same as using the implicit function theorem. So what we need to compute is we'll take the total derivative with respect to capital Q of this equation over here. So total derivative of capital Q of P is just going to be P Q times Qi. But then we'll also notice that, well, we are interested in how does little q respond to changes in big Q. Well, that's the second aspect over here. So the second term here is going to be P prime Q times dQi d big Q. Second term depends on Q again, so it's P prime Q. And the final term again depends on little q, but little q again itself depends on big Q, and we want to figure out by how much. So we get the contribution C double prime I Qi times the Qi dQ, and that equals 0. That's what we get by taking the total derivative of the first order condition. Now from this equation, this equality, we can actually work out what the little q, the big Q, what is in here, what it is, just by isolating it here. So we find the Qi dQ just by rearranging this equation in the numerator. Well, we have all the terms that we see here. If we shift all the terms involving this derivative to the right hand side, in the numerator what remains is this contribution over here and the contribution over here. Qi plus prime Q. And in the denominator, we get sort of the factors that are multiplying this, the derivatives over here, but with a minus sign because we shifted this to the essentially to the right hand side of this equality. So C double prime I Qi minus that one P prime Q. So this is just solving for dQ dQ from this equation in this linear equation essentially. So this is the expression for the total derivative of little q of the output from firm I if the total output in the market is changing. So this is how fast little qi changes with big Q. And as I mentioned, actually this is going to be a negative number. So I'm going to write, actually Farrell and Shapiro write this number as minus some positive number. And this positive number they encode as some lambda I. So it will be specific to firm I, right? So for instance, in particular because Ci is dependent on I, and also Qi is actually dependent on which firm you're looking at. So this number is minus lambda I, and this is going to be smaller than 0. So this lambda is going to be a positive number in particular. What is this lambda? Well, that depends obviously. It's going to depend on what's the demand equation and what's the cost function for these particular firms. For each different choice that we make, there will be different outcome basically for what this number is going to be, but it's going to be negative, and basically that encodes that optimal response curves actually are downward sloping in this Cournot model. So we're going to actually use this lambda, or the fact that the way in which these firms are adapting, the outside firms are adapting their output in response to a total output expansion, perhaps in the market. So the degree to which they respond to that, we encode this by lambda. We're going to use that later. Okay, so let's go back to the slide then. So here we again see that same expression for how fast. So how much do outsiders basically contribute to this change in Q? So they're offsetting an increase in Q by a bit, and this bit is called lambda essentially. So let's now look at the incentives of the merging parties. So these merging parties, before the merger, they were in this happily sitting in this equilibrium, and in their equilibrium, they faced first order conditions. They solved those, and they made sure that indeed their individual quantities Q1 and Q2, that they solve their individual respective first order conditions, which are reproduced over here. So these will be the first order conditions pre-merger for both firms 1 and firm 2, the regular first order conditions. Now the question is, when these firms go together, 1 and 2 go together, they create a joint firm, capital M, the merged entity. Would they want to increase their total output, so Q1 plus Q2, or would they want to decrease their output in case all the other firms would not be reacting? So if all the rivals kept their output constant, what would the merging firms do? Well, it's going to depend, right? It's going to depend on their cost synergies. Or mathematically speaking, it's going to depend on the sign of their joint profits derivative. So the derivative of their joint profits is just again any firm. If they kept the total output at the same level as before, so they were Q1 and Q2 before the merger, if the merged entity still produces Q1 plus Q2, well then the derivative of their joint profits will be exactly given by this expression over here. Now typically that will no longer be 0, so there will be some response. So if it's 0, then we satisfy the first order conditions, but typically after the merger with the changed ownership conditions and the changed marginal costs for the merged firm, this will not be 0, so there will be either an incentive to increase output or to decrease output from that point onwards. Well, which is it going to be? Well, that depends on the sign of this derivative, right? So if the derivative is positive, the profit derivative with respect to their total Q, the total output is positive, then what would you like to do? Well, you would like to increase your quantity, right? Because increasing quantity with a positive derivative means raising profits. Whereas if this expression is going to be negative, then you would like to decrease your output, because then negative derivative means if I decrease my output, profits is actually going up. So if you're interested in answering the question, well, what does it take for these merged firms to actually expand their total output, so for price to be lowered, we need this total expression here, this derivative here, to be positive. So if that's positive, then indeed the merged entity would like to increase its output, it's called QM in the new equilibrium, beyond the output that they had joined together before the merger. So it would then be bigger than the equilibrium quantity, would then be bigger than the quantity that 1 and 2 would have been producing before the merger. If that happens, total quantity produced by M is going up. Obviously, the other firms are going to respond, but they're going to offset this only partially. So the total quantity will also still go up. And then price indeed goes down. So price going down means obviously immediately that the consumers are going to benefit from this. So that might be nice. So what does it take for this QM to be bigger than Q1 plus Q2? That's a relevant question that we want to answer here. So I reproduce it here. So for total quantity to go up, we need that this derivative and the original pre-merger quantities for firms 1 and 2 needs to be positive. So let me write that on paper again, and let's see what we can do with that, or what Farrell and Shapiro actually do with that condition. So we ask the question here: Are the merging firms going to expand output compared to their pre-merger output Q1 plus Q2? So that's the case as I just reported. If their first order condition, or sorry, if the profit derivative, I should say, the profit derivative at the pre-merger quantities Q1 plus Q2, where in which case the total quantity in the market still is the same capital Q as we had pre-merger, and of course I need the prime, because I'm just writing the derivative of profits here, plus, well, the second component here is P of Q, and the third component is its new marginal cost, evaluated again at the pre-merger quantities. If they want to expand output, that's going to happen as long as this expression is bigger than 0 before they do this expansion at the pre-merger quantities. If that's the case, they will like to have to produce a quantity Qm that's going to be bigger than Q1 plus Q2, and the price is going down in the market. Total quantity goes up, price goes down. So this is the condition for these firms to expand output. Now we know that before the merger, these two firms were actually just profit optimizing, so they were satisfying their own individual before merger first order conditions, each one with equal signs. So we know that before the merger, we know that for firm 1 it solved P prime Q times Q1 plus PQ minus its C1 cost, marginal cost, was equal 0. That was its first order condition. Similarly for firm 2, it satisfied the same equation, but now for firm 2. So this holds before merger. So we are wondering, can we have this condition for, we call that star, for which is going to determine whether these firms want to expand output, and we know that we can use that before merger both firms were satisfying actually their individual first order conditions. Can we do something with this? Well, let's add up these two first order conditions before merger. We see what we get here is P prime times Q times Q1 plus Q2 plus, well, there's two P's over here, 2 times P minus C1 prime minus C2 prime equals 0. So let's use this expression over here, and let's use that actually plug that into this star equation that we want to, in particular, we can actually plug it in for the 0. So the 0 over here, we just put actually the sum of those two first order conditions. What you then see is that this term over here, P prime Q times Q1 plus Q2, actually also appears here. So those two are cancelling. So what we're left with is this second two terms here, this method two terms, PQ minus CM prime evaluated at Q1 plus Q2 should be bigger than, well, this term was cancelled, so the second term over here, 2P minus C1 prime minus C2 prime. So combining this condition on the derivative of total profits at the before merger quantities being positive, so which is the condition for firms to have an incentive to increase their quantities, combining that with the first order conditions that we know were satisfied before the merger, we see that, well, that's going to happen as long as price minus marginal cost at the pre-merger quantities, price at the pre-merger price, minus marginal cost for the merged entity at the pre-merger quantities, needs to be bigger than this thing here, and I'm going to rewrite this the thing here as P minus C1 prime plus P minus C2 prime. Why am I doing this? Look at this expression over here. It's just the margin that the merged entity has before the merger, before merger prices and quantities. I'm relating that to the margins that these individual firms had. So margin for M, and this is the margin for 1, and the margin from firm 2 at before merger quantities. So when does this merged entity has the incentive to increase its quantity? Well, whenever its margin at pre-merger quantities and prices but that the new, more efficient marginal cost is bigger than the sum of the margins of the original firm 1 and the margin of the original firm 2. So let me go back to the slide then to see that once more. So we see that here as well. So here again, this was the derivative of the merged entities profits and the pre-merger quantities Q1 plus Q2. So supposing it did not change its quantities, what does this derivative look like? As long as this is positive, the merged entity will think, oh, I had better increase my quantities, my total quantity compared to what we were producing before, because that's going to increase my profits. So with this condition satisfied, total quantity in the market is going to expand, prices are going to go down. We know that before the merger, firms were satisfying their own first order condition. I added those up, it gave me this equation, and combining those, I find that the price margin after the merger should be bigger than the sum of the price cost margins of the two individual firms before the merger. So the result of this is what I just said. So the sum of the margin after for the merged firm should be bigger than the sum of these margins. So is that easy to satisfy? Well, obviously it requires that C prime goes down as a result of the merger. So we would like marginal cost for the merged entity to be lower for this margin over here to outweigh the sum of these two margins over here. But actually it has to grow smaller by quite a bit. Because what's certainly not enough is for there to be just a reshuffling of production to the lowest cost firm. So even if CM, the merged entities firm, if it were to have a marginal cost that would be equal to the lowest marginal cost of either firm 1 or firm 2, so we're just transporting or reallocating all production to the least costly unit that we have basically out of these units 1 and 2 owned by the merged entity. Even if that were the case, we would still not be satisfying this condition. But then we would say C1, so firm 1 would be the more efficient one, so C1 prime is the lower one. And still we do not satisfy this because here we have P minus C1 prime in that case. Well, certainly that's not going to be bigger than itself, P minus C1 prime, plus something, because this even margin 2 would still be a positive thing as long as 2 was producing before the merger. So what this means, what this tells us, is that in order for these firms to have an incentive to actually increase their production, the cost efficiency should be bigger. So the reduction in prices, the reduction in cost for the merged entity CM should lead to a lower marginal cost than even the lowest marginal cost of either firm 1 or firm 2. So just reshuffling is not sufficient to lower price. We need a pretty large efficiency gain to make sure that this happens. What happens if this inequality holds is that if you can manage to get such large cost efficiencies, only then do total prices go down and do consumers benefit from this merger. So if consumer welfare is going to be sort of crucial here, if we concentrate on that, we really need large cost efficiencies. But we are economists, we don't only care about consumers. We might say, well, okay, prices might go up a bit, but if they are offset by much larger efficiencies on the production side, we might be willing to allow this, right? So we might be caring more about total welfare than about consumer welfare. So suppose now indeed that price indeed goes up. So of course consumers are going to be disadvantaged as a result. Q is going to go down, total quantity in the market, price is going to be going up, consumer surplus obviously is going to go down. So we're going to allow this, or we might want to allow this if we care about total welfare, if indeed there is such a large cost efficiency in terms of reallocated production, that indeed the producer surplus goes up by more, total producer surplus. So is that going to happen? Well, we don't know exactly, because we don't know ex ante perhaps what this merged entity's new cost would be. We can ask them, but they will be very inclined to overestimate this for us in order to convince the regulator or the competition authority to allow this particular merger. So what Farrell and Shapiro do to get some workable answers, so without having to rely on the reports of the merging parties, is, well, the following argument. Well, if these merging parties are happy about merging, then let's assume that they are sort of rational managers who have the interests of their owners in mind. Presumably, by having this merger, they expect they will be better off, right? So somehow their cost efficiencies are large enough for them to overcome essentially the merger paradox argument. So let's just assume that the mere fact that we see this merger being notified, being contemplated, these managers at least know that cost efficiencies are large enough for them to benefit out of this. So the profit of the merging parts is going to be, at least the change in profit is going to be bigger than zero. Now, what happens to total welfare? Well, if we can verify that the total welfare of all the other players together is going up, well, then we might be then total welfare will actually go up. So why is that? So who are the other players? Well, it's the rival producers, right? So firms 3 up till n, and it will be the consumers. So consumers are going to be worse off. So the change in total surplus is this, right? Is the change in the surplus of the merging entities plus the change in consumer surplus, which will be negative if prices go up, total quantities go down. But we also have to include the change in total profits of those outsider firms, and that might well be or will typically be a positive effect. Well, assuming that the merging parties are benefiting, this thing will be at least zero. What suffices for us to see if total welfare goes up is if the effect on the outsider, the non-merging parties, the outsider firms, on their profits of this merger is going to be larger, positive, than the negative change in consumer surplus. So can we find conditions under which indeed this is true, where the benefit in terms of producer surplus for the outsiders outweighs the disadvantage in terms of consumer surplus for the consumers? So let's have a look at that. So argument again is this. We assume that delta, the change in producer and profits of the merging parties, is bigger. So total welfare then rises and goes up when the sum of consumer surplus and the rivals' profits are going to go up. So what is that sum? So we have to look at consumer surplus again and at the outside producers. So consumer surplus, of course, is the area below the demand curve, right? Or rather, the area between the demand curve and the price. So that's typically what we know the consumer surplus is. And to compute an area, that just means computing the integral under this demand curve. Which integral? Well, the integral between 0 and the total quantity Q. And you have to subtract from that the level of the price at the equilibrium level, at the Q level. So this represents this area that we know, it's more or less triangular area under the demand curve. That's consumer surplus. Then we have the outsider producers. Well, what's their surplus? What's their profits, right? The profits is price times quantity minus their costs at their production level. And the question is, how do either of these change as total output Q drops? Because we are assuming here we are in the bad situation that indeed prices go up, total quantity goes down. Might still the change in outsider surplus, outsider profits, might that outweigh the negative effect on consumer surplus? So we are wondering whether this total welfare rises. Well, that happens if this sum is indeed going to go up as total output Q is going down. So the question is, can we compute how fast this total outsider welfare rises as capital Q, total output in the market, goes down? Let's have a look. So what's the approach to this, computing the effect on outsider profits that Farrell and Shapiro take? So we're going to suppose this. So we're going to look at this. We're going to look at first and just at the question, what happens to this outsider surplus if Q only change by a very tiny amount. So let's call this tiny amount delta Q. So it's almost the same as the pre-merger quantity. Just look at it, they call this actually an infinitesimal merger, so a very small effect, in particular on the total quantity that's produced. It's going to be delta Q, which is a very small negative number. So Q goes down by a very small number, delta Q. What would happen in that case? Well, there will be very small effects on consumer surplus and very small effects on outside producer profits. And we want to look at the total sign of the sum of these two effects. So when we know what the effects of a very small change in Q, then we can go on and estimate or try to compute what's the effect of a bigger change. What's the bigger change? Well, that's just a lot of small changes one after the other. So essentially what we are going to do is look at the small change, and then what remains is to integrate all those smaller changes to estimate the total effect for this bigger change. So let's look at the small change. So how does consumer surplus respond to a small change in quantities? So we have consumer surplus over here is the blue area. So this curved object here is the particular demand curve that we're looking at. So just any decreasing function. I'll just give an example here. And we are interested indeed in the area, the blue area between the demand curve and the price at market clearing, essentially. So that's total consumer surplus. So again, how do we compute this? We compute this as an integral. So this blue area is just the integral between 0 and the actual quantity produced in the market, which is basically this quantity over here. And what are we integrated? Well, we're integrating basically under the demand curve, between the demand curve and the actual price. Is the second thing over here in the market. So can we actually say something about how this consumer surplus expression, how that is going to change as a result of a small change in quantities delta Q? So let's have a look at that. So I'm going to go back to paper again. So here we are on paper. So what we're interested in again is the total consumer surplus. Consumer surplus again, area below the demand curve, and it's given in general as an integral. The integral from 0 to Q of the price going from at quantity 0 to Q. So S is going to range the integration variable here ranging from 0 to Q minus the price at the market clearing level, so at Q, integrated over this integration variable S. So this is consumer surplus, and this was the blue area that we saw, and we are interested in the change, first order change of these consumer surplus with respect to Q. So what's the derivative of this expression as we change Q by a little bit? So let's take this derivative. So it comprises of two parts. So first of all, we see a Q over here, and secondly, we see a Q over here. So for this first part, taking the derivative, well, it's basically a fundamental theorem of integration. If we take the derivative of an integral, we just get what's below the within the integrals, the integrating function. So that in this case is going to be PQ minus PQ. So evaluating it at the top point here. So that's the first part of this derivative. We take the derivative to this Q. And secondly, we see this Q over here. So we also have to take the derivative under the integral sign. So we have to add minus this minus over here, the integral of P prime of Q ds. So how much is this? Well, obviously, the first bit over here is going to be 0. PQ minus PQ is 0. So what's left here is this P prime Q, which does not depend on S, times this integral over here. So that's going to be minus P prime Q times, well, the interval of 0 Q of 1 essentially is just going to be Q minus P prime Q times Q. So this is just the computational argument for why this. So we can also actually see this at work if we just draw a simple graph to check that this is indeed true. So we have this demand curve over here, and we might have Q and P. So what happens if we change Q by a little bit? So we go down to a slightly smaller Q. Of course, the change in consumer surplus is more or less precisely this area essentially. So how large is this area? Well, of course, it's not exactly a rectangle, but if you take a very small change, which is what we're doing if we look at derivatives, very small change, we can more or less ignore this very small triangle over here. So how large is this rectangle? Well, to first order, it's going to be equal to the change in prices, change in price, times the total quantity times Q. So how large is the change in price? Well, change in price is just dP dQ times the change in quantities times this quantity over here. Or in other words, it's P prime times Q times the change in Q. So the change in consumer surplus is this expression here times delta Q. This delta Q, I took this here to be negative basically, so that explains this additional minus sign if you think about this a bit more carefully. So this tells us that what we did here computationally or just analytically also makes sense if we look at the picture essentially. Okay, so this is the change in consumer surplus. So let me go back to the slide then. So here we see it again. So the first order change in consumer surplus is just Q times P prime with a minus sign. So P prime is negative because downward sloping demand curve. So this just says if we expand Q, if we make Q larger, the consumer surplus goes up. Yeah, that's natural. And we will be actually interested in reduction in Q. So if we make Q smaller, then indeed consumer surplus is going to go down. So next we have to look at the other part of this, which was the surplus of the outsider producers, or in other words, the profits of the outsider firms, the non-merging firms. So what are their profits? It's just P times their individual quantity minus the cost, C of Q, CI, essentially of QI. And we know that these, before the merger, these firms were satisfying the first order conditions. So we're actually going to use those conditions in a bit. So we're asking, so what's happening to these profits, to the profits of these firms as capital Q, the total output in the market, changes by a small amount delta Q. I'm particularly interested in this delta Q being negative. So as a result of the merger, total output in the market is going to contract a little bit. It's going to get a little bit smaller and price going up. So it's going to happen to these firms, or the outsider firms, in response to this decrease of total quantity. They are going to, first of all, expand their output. Because that's their best response, right? So there's a small change in total output. They will offset part of this small change. How much? Well, depends. This depends on the dQi, their individual output derivative on the capital Q, the total output in the market, which is going to be this negative number. So they are going to offset changes in the total output. And you recall here that we are actually going to make use of the fact that we already gave this a name. So this was this lambda that we saw before. So that will turn up in a bit. And so that's one effect. On the other hand, there will also be, of course, effect on because total profits are going up. So what's the total effect on the outsiders? It's basically this. So let me do that on paper again. So we had yi total profits for firm I is P as a function of Q times Qi a minus Ci of Qi And we're interested in how does this total profits, how does it change as we change big Q, total output in the markets, or in other words, what's the derivative of their profits, or from I's profits as Q is changing. We want to know what d by I dq. That's obviously going to be the derivative of P pi times QI. That's the first effect, so that's a price effect. Secondly, there is an effect that little q is going to change because they are going to respond to this change in output big Q by also adapting their own production little q. So that gives me plus PQ times dqi dq. So that's the positive effect, or the one effect here. The other effect is, of course, this cost is also the little q is also appearing in cost, and we also have the contribution by the chain rule, essentially. CIQI times EQI dq. So this is the total effect on profits as Q is changing by bit. So this is good. We know then that what the total d pi dq is going to be. We can write it actually as p prime q times qi plus p minus c prime qi times this dq I dq. So this is the change, or the derivative of total profit from I with respect to the complete quantity in the market. Let me show that on the slide again to check that. So here we are. So we already covered this. So the aggregate effect on the outsider's profits is basically over here. So this is the derivative that we just computed, and it takes this particular form. So now what do we want to know? Well, we need to add up. So the question was, how is total outsider profit, so the sum of consumer surplus plus outsider producer profits, how is that responding to a decrease in demand? Or in other words, what's the derivative of the sum of consumer surplus and the sum of all those outsider firms? How does that depend? What's the derivative on capital Q? So that's basically this derivative. And of course, the interesting question is this going to be positive or is this going to be negative? So let's add up those two contributions that we just had, and let's add them up on the paper again. So the sum of total outsider profits and the sum of consumer surplus as we change Q plus this sum over all these non-merging firms, which remember all these firms with index I bigger than 2, because 1 and 2 were the merging firms, of these profits over here, pi I dq. Well, what is it? Well, let's add them up. Consumer surplus we had over here, its derivatives was minus p prime q times q, and we have to add to this plus the sum over all I bigger than 2, the outsider firms, p prime q times qi plus p minus ci prime qi dqi dq. Just copying this expression here, and I have to sum over all these i's, this whole expression. So this is just the two contributions that we just computed. So what can we do with this? Well, this was just some rewriting, but we can actually now use the fact that these outsider firms actually they're satisfying their first order conditions. So the first order conditions tell us for the outsider firms, so the first order condition for these firms were p prime q times qi plus p minus c prime equals 0. That's the first order condition for firm I. And we're going to use that. We're going to plug that in actually in particular over here. So let's plug that in. So P minus C prime I is minus P prime times Qi. So is minus. So this is what we're going to plug in over here. So what do we get? So dCs dq, just copying this over this line over here, plus the sum of the changes in the profits for these outsider firms is going to be minus P prime times the total quantity minus the sum of all these outsider firms times sorry, let me put the plus here actually, plus this P prime, I will use that later actually, plus P prime Q times Qi. Now I'm plugging here actually the P minus C prime. I'm going to write it as minus, by using this first order condition here, minus P prime Q times Qi dQi dQ. So I've substituted this bit over here by the minus P prime Q over here. This is added up. So now you see why I'm doing this, because now I get this P prime Q that actually pops up both over here and over there, and actually also over here. So this P prime is actually popping up all over this equation, so I can actually take it out of this expression completely. So I write this as minus P prime, well, times what? Well, first of all, times Q. Secondly, I've minus P prime, taken that out, so there's a plus P prime here, so I need to write the minus over here to cancel the minus over here to get this term here. So minus the sum of all those outsider firms quantities plus, because we have minus P prime already accounted for, plus the sum of all these Qi, dQi, dQ. Now, if we look closely at this expression here, this total quantity in the market minus the sum of all the quantities of the outsider firms. Well, we recognize that. The total quantities will show is the sum of all firms' production. We're subtracting the total output by the outsider firm, the non-merging firms, or what remains here is the production of the insider firms. So firm 1 and 2, which are actually merging. So we can rewrite this first part here as the production of firm 1 and firm 2. So total production minus the production of the rival firms is just the production of the insider firms, the firms which are merging. Plus, of course, the second bit here, sigma I Qi dQi dQ. What remains here is to what this basically is going to work for us. So what remains is to analyze what this means. So P prime is of course negative, right? This is the slope of the demand curve, so minus P prime is positive. And we are wondering, so how is total aggregate outsider surplus, which is consumer surplus, plus the sum over the profits of the outsider firms, how does that respond to big Q? Well, if this expression, this derivative is going to be negative, the overall sign of this thing is going to be negative, then what this means is if quantity is going to contract, so if quantity is going to go down, then total outsider surplus is going to go up. So then we have a gain in total surplus. So is this positive or negative? That's the question. So this thing, of course, is positive, right? Minus a negative number. So the question is this second bit here is positive or negative? Or in other words, when is this going to be negative? Negative if Q1 plus Q2, Q1 plus Q2 is smaller than minus the sum of Qi dQ. Well, this thing we recognize or gave a name essentially. This dQ was this lambda thing, right? So I can concisely write this as Qi times lambda I. So the question is the total quantity produced by the insider firm, the merging firm, before the merger Q1 plus Q2, is that smaller than the sum of the response factors, the lambdas, for each of these individual firms, and multiplied by their quantities. And it not actually helps to divide every term over here by Q, because if I divide by capital Q, the total quantity in the market, Q1 divided by capital Q, that's just the market share of firm 1. The quantity of firm 2 divided by the total quantity is just the market share of firm 2. And I'm wondering whether that's going to be smaller than the market shares of each outsider firm multiplied by their response factor, lambda, which, remember, lambda measured something that depends on the form of the cost function of the demand function. So it will differ by model, basically, differ by production technology, by the demand technologies. So as long as this holds, as long as this inequality is smaller, then the second term here will be negative, and in other words, the total derivative here will be negative. So what that means is, if total quantity capital Q, if that's decreasing, then total outsider surplus, outsider welfare, is going to go up. So that means that a merger which does reduce quantity, so increases price, will nevertheless have a positive effect on total outsider welfare. So let's go back to see that in the slides. Here we see again the total outsider surplus. How does that respond to changes in the total quantity? Well, I just derived basically the expression over here, and we see it sort of simplifies to a fairly simple expression in terms of the total market share before the merger of the two merging firms being smaller than the weighted average value of these lambdas, these response lambdas, of these individual outsider firms. So now it depends on obviously on what this expression will be, on the, as I mentioned, on the form of the demand function and also on the form of the cost functions. So let's have a look. Well, let's first summarize this a little bit, just to see what we did. So we assumed so far that these merging firms, so firm 1 and 2, the fact that they are merging means their profits will be going up. So on that side, there's a positive surplus effect. It's their profits, but still it's total surplus, right? We assumed also that prices are going to go down, so the total quantity is going to be reduced as a result of this merger. So prices are going up, total quantity is going down. So consumers will be worse off. But still, total welfare might go up because of these efficiencies and this reshuffling of production. And well, when is that the case? Well, a sufficient condition for that is if total outsider surplus goes up. Well, this total outsider surplus, or its consumer surplus, plus the sum of outsider profits. Well, that happens as long as, for a small change in total quantities that are being produced, as long as that market share of the firms 1 and 2, so SM is just S1 plus S2, the sum of the market shares of the merging firms, as long as that's smaller than the weighted sum, weighted with these response parameters lambda for the outsider firms, weighted by their market shares, as long as that SM is smaller than this weighted sum of the outsider shares. Now, so we did this analysis for a small delta Q. Now what remains is to do the analysis of what happens if this delta Q goes bigger. And the idea here is, well, a big step in Q is just a lot of different small steps. So as long as all these small steps along the road continue satisfying basically this expression, then we are fine. Then the sign of the change in outsider welfare for all these small steps together will be the same as the sign plus or minus for each of these individual steps. So Farrell and Shapiro actually give some sufficient conditions for this to also hold indeed for these larger delta Qs, larger changes in Qs, that we will actually not bother with that much. So for quite typical demand and supply conditions, this will actually be the case. So let's look at this in terms of picture actually. So what is this picture? So as you can see on the horizontal axis, I plotted changes in profits from the merged parties. So as a result of the mergers, do their profits go up? Well, that's the case as long as the merging parties delta pi m is positive. So the right-hand side basically of this graph is the positive profit effect on the merging parties. What I plotted on the depicted on the vertical axis is the change in outsider surplus as a result of the merger. So it was the change in outsider surplus. Well, that's the change in total surplus minus the change in insider surplus, right? So, this difference here is just the sum of consumer surplus change plus outsider firm change. So now what we can recognize is, well, when does total surplus go up? Well, whenever the sum of outsider surplus plus insider surplus goes up. Well, which part is that? Well, that's the total area above this diagonal line here. So in both in area number A, area B, and area C, that's the case for it. So all configuration of A, B, and C will correspond to situations where, as a result of the mergers, total welfare W is going up. Well, if we use as a screen essentially for evaluating mergers that total outsider surplus goes up, well, which area is that? Well, that would be the area above the horizontal line, right? So the vertical line measures total outsider surplus. So if we just measure whether total outsider surplus goes up, then we are looking at the positive effect here, at the positive side here. So we would capture both A and B and actually also this bit. If we now only look at mergers that are actually proposed, well, that's the mergers for which delta pi m is positive. So that will be on the right-hand side, basically, it's both B and C, and actually also this bit over here. So if we are looking at mergers which pass both the test that they are actually proposed, and the merging parties make a profit, and they satisfy the test that outsider surplus is going up, what we end up with is just area B. So the area B mergers will be cleared by the merger authority, by the competition authority, because total outsider surplus is going up, and they will indeed be proposed by merging parties because insider parties are happy, they gain by merging. What we miss is those welfare improving mergers which are in region A. Or which are those? Well, those will be the one in which the gain in outsider surplus would outweigh the loss in profits. So on the left-hand side of the picture, loss in profits for the merging parties. So we would like to have those mergers, but merging parties will never propose those routes. So we can forget about those occurring. So what happens over here? Well, over here, actually, the gain in area C, the gain in the merging parties' profits is so large that even though all the outsiders jointly are losing because we're on the lower side of this picture, total surplus still goes up. Well, those we are banning, though if we are just interested in total surplus, we would have liked to actually allow those mergers. So those are the ones that we are missing if the competition authority just focuses like we were doing on total outsider surplus. So again, this is in the paper by Farrell and Shapiro, and by all means read that actually. So when is merger welfare improving? Well, certainly if the merger is proposed, so delta pi m is positive, and if total outsider surplus goes up, or in other words, the total market share before the merger of the merging parties, Sm, is smaller than this weighted sum of these lambdas. Well, what is lambda? What was it measured how steep basically the response functions were, so it measured dqi over the capital Q. And again, well, that depends on what the cost functions ci of Q were, and also what the demand function looked like. If you look at linear cost, for instance, and the linear demand function, you can easily check that this lambda, this expression over here, will actually turn out to be 1 for all firms. So I want you to check that actually. So for linear cost and linear demand, so constant marginal cost and linear demand, so if you wish are the most simple basic model, a merger will increase welfare, with all these lambdas being equal to 1. A merger will increase total welfare certainly if the total share of the insiders of the merging parties before the merger is smaller than the total share of the outsiders before the merger. So when does that happen? Well, if the merging parties ex ante have less than 50% of the market share. So that's a nice condition. This of course validates that looking at market shares might be a good thing, in particular for this particular linear cost, linear demand model. So if the total market share of the insiders is less than 50, go ahead, allow this merger. Apparently these merging firms are better off. Also, outsiders jointly are better off, even though consumers might lose. So if you have at heart the total welfare effects, this is going to be a merger that we would like to allow. So how can we actually compare this to this merger paradox result, the Sallon-Switzer-Reynolds result? This merger paradox told us, well, for these insiders to be happy, they need to merge to almost monopoly. Well, that's not what's going on here. Well, then we forget, of course, that what we also have here is we have these asymmetric costs. So costs were not the same, and there was this efficiency effect that also sort of benefits the insider firms. So with efficiency effects taking place here, so assuming here essentially that these insider firms have such a large efficiency that they at least gain in profits. The second example would be quadratic costs, but linear demand. So it's a linear demand function, as you can see, but costs are now quadratic. So marginal costs are linear in quantities Q. And this K would be different for each different firm. So firms with large K have a big cost advantage and low cost. And then so we'll have a large market share in this market, where firms with a high K basically would be the inefficient firm. With the low K would be the inefficient firms and have a smaller market share. So you can again compute what the lambda is for this particular market. So it will be different because now the cost function will be different. So if you recompute now what is this response function lambda, what does it look like? You'll easily find that this will be hopefully that this lambda will be precisely this form Q over P, which will be different for each firm. And actually you can rewrite this as the market share of firm I divided by the overall epsilon, the overall market elasticity, absolute market elasticity of the total market. So what now is the condition for outsider gains? So again, it's the same condition. Total market share before the merger of the merging firms should be smaller than this weighted market share of the insider firms weighted with its lambdas, but now these lambdas that are computed for this quadratic cost function, so taking this particular form. So if we plug that lambda form for this particular market in, what you find here is this SI squared term divided by epsilon. So if you look at this a bit, you recognize this basically as the HHI for all the insider firms, right? The sum of the squared market shares for all the outsider firms. The sum of the squared market shares for all the outsider firms, the HHI for the outsider firms, divided by the market elasticity epsilon. So as long as the insider market share, the merging party's market share before the merger, is smaller than this HHI for the outsider firms divided by epsilon, we will see a gain in terms of outsider surplus. So why do we see this gain? Well, actually, as a result of this merger, what's going to happen? Well, the more concentrated essentially these outsider firms are, the larger the right hand side, so the larger these outsider surplus gains. Why is it? Well, if these firms are large to begin with, they must be the more efficient firms, right? More efficient firms have larger market share ex ante. So the larger this thing is, means the more efficient the outsider firms are. Or what does the merger do? It's going to shift some production from insider firms to outsider firms. Well, if these outsider firms are actually more efficient, well, that's a positive effect, right? So that's a good thing. It's a welfare positive effect of this merger. So here we see is one additional effect of a merger. It shifts production to more efficient firms. And if that effect is big enough, we would like to allow this merger if we have total welfare as our objective. So let me wrap up this lecture. So we looked at mergers in Cournot market. We first looked at the merger paradox. Then we saw that we need some efficiency effects to actually to make sure that in the Cournot market there will be actually an incentive to merge, apart from mergers to almost monopoly. So the merged entity might be more efficient, but there's an additional efficiency effect, which will be the shift in production as the outsider firms, the rivals, expand their production, which is a positive effect if these rivals are actually more efficient. So next week we'll look at this other reason why the merger paradox might fail, and that will happen if this is not actually quantity competition, but if we're looking at a model or a market where there's actually price competition. So next time we'll look at a word-round market, so a market with differentiated goods, so there will be some market power. You could think about consumer products in the supermarket, for instance. And we'll look at both theory, but we'll also look at some merger simulation. So you can have a look at Malta chapter 5. And actually next week we'll also get the first presentation on the one of the first actual merger cases, which was this Ryanair Aer Lingus merger case. So see you then. Bye-bye.